Is on composites and inverse, and we're going to explore this concept by having a look at a couple of problems taken from exercise 7b in the text. The first problem that we're going to have a look at is question 20. It states, let G be a function with a domain of all real numbers across all real numbers of x, such that log e gx equals ax plus b, given that g0 equals 1 and g1 equals e to the 6. And the task that we're being asked to do is find a and b and hence find gx. I just want to highlight here that the final task is really to state what gx is going to be. Okay, so let's start by exploring g0 equaling 1. And what does this mean? This means when x equals 0, gx equals 1. And we're going to put this into the original equation, which was log e gx equaling ax plus b. And what we're going to focus on is this gx. Here it's stated as gx equaling 1. So we're going to have 1 there. Log e to the 1 equaling, and this x here is 0. This x here is 0 plus b. So what we're left with is log e to the 1 equals b, and b here should equal 0 because log e to the 1 equals 0. Therefore, we can say that for g1 equaling e6, what this means is that when x equals 1, gx equals e to the 6, and we would use the same equation. We might fast track this though, so what we can write it is log e to the 6. Remember, this e to the 6 has come from that gx, and this equals a1, which has come from here, plus b. Remember, b equals 0, so what we have here is log e to the 6 equals a times 1, which is just a, and this can be written as 6 log e to the e equals a, and log e to the e is just 1, so a equals 6. So we found our values of b, we found our values of a, and now we need to establish what gx equals. So if we say that log e gx equals 6x, then we can say simply that gx equals e, our base, to the power of 6x. And that should be our final answer, which is correct. Okay, moving down forward to question 21. This set of problem is about inverse, or using inverses and being able to find our inverses. Now what I'm going to do is I'm just going to focus for the first part on this question. Okay, so part A, because part A really will describe how you would do B, C and D. Okay, so what we want to do with, if we're having fx equaling e dx plus e to the minus x on 2, what we're doing with our inverse is we're saying x and y, we're going to swap them, and this would give us x equals e to the y plus e to the negative y on 2. Now we can do a simple thing to do here is just bring the 2 over this side, and we get a nice, easy, simple equation that looks like that. It's not exactly simple, but it at least gives us some reference to be able to start finding our inverse. So if I start off from here, 2x plus, or sorry, not plus, equals, actually I'll take this back, and I'm just going to write this a little bit further out, and I'll explain why. Because what we want to do is we want to resolve part of this function, and one part of this function that is quite problematic is this e to the negative y. It's actually a reciprocal function of ey, but we want to be able to resolve it. Okay, so the way that we can get around this is we can multiply both sides by ey, like so, and that gives us now a function of 2x ey, y squared, or e to the 2y, plus 1. And we can resolve this in terms of 0. So we can have e 2y, okay, minus 2x e to the y plus 1. And what we're going to do there is we're going to have to complete the square. So here, and I'll get a little bit creative, but complete the square. Now, this looks quite problematic because you're having to deal with exponentials, but you really have to rely upon the principles that you would have learned prior about completing the square. Okay, so completing the square, what we're going to do here is I'm going to set it up. And remember, you do this. This part here is really important when you're completing the square. So you have to halve the middle term, okay? Halve the middle term, the coefficient of the middle term, which is this, and then square it. And this gives rise to a neat expression where we can say ey minus x all squared, okay, minus x squared plus 1. And then we can have this equaling ey minus x squared plus 1. What we can do here is we can square root both sides. That means that we get rid of that square, and we've got ey minus x equals x squared plus 1, all square rooted. Ey equals x plus x squared plus 1, square rooted. And what we would do is our base is e, so we're going to log both sides, or log base to the e of both sides, and that would give us and this is our inverse, and it means, okay, and we can state here, therefore, fx is increasing, strictly increasing. Okay.